Great timing. Hello, everyone, and thank you for tuning in for Adventures in Dotnet. You may find it hard to believe, but Shawn joined literally a second after we hit the go live button. So, anyway, I'll take the lead, even though Shawn is already here. My name is Adam Furmanek, and thanks for joining, folks. Today with me we have Shawn, our main host, and we have also Simon Cropp, our guest for today. So, hello, folks, and glad to have you on the show today. Simon, if you could introduce yourself, tell our listeners couple words about yourself, where you're dialing in, what's your work, and whatever you'd like to start with.
Sure. So as you said, I'm Simon Cropp. I work and live in Canberra, Australia. So it's -2 outside. It's 6 a.m. And I also want to apologise for any coughing because I had COVID about a week ago. So there's a bit of residual damage there. But yeah, that's me.
Cool. Very nice to meet you. Shawn, would you like to say hi to our listeners?
Hi, everybody. Hi, Simon. Nice to meet you.
Hey, nice to meet you too.
Yeah.
So glad the reboot worked.
Yeah, much better. There's all those tech issues. I had to call, somebody that actually knows things about computers. So,
Shawn, where are you dialing in from today?
I am at home. I am in Idaho. So it is about 78 degrees outside. I don't know what that converts to in Celsius, but it's summer here. So it is now 1:23 p.m.
So just to help our listeners, 70 Fahrenheit should be around 21 Celsius. And I'm dialing in from Krakow in Poland. And I think I'm beating Shawn, even though it's 10:20 p.m. here. I feel like it's 30 Celsius. That should be something like, 84, 85 Fahrenheit? Something around that.
That's beach weather.
Cool. Yeah, that's a very, very nice summer weather here. Okay, so Simon, today's topic is snapshot, testing with snapshot testing. Is that correct?
Yeah.
So if you could introduce our listeners to what that is and why you find it interesting.
So for starters, snapshot testing is used in a bunch of different technologies. It's not specific to .NET. I'll focus on the .NET side of it because that's what I'm familiar with. But snapshot testing is kind of a bit of a misnomer. It should actually be called serialization assertion, but that's a bit confusing. So what I mean by serialization assertions, the snapshot testing concept only applies to the assertion part of tests. So when you look at code, the actual snapshot part will be replacing or complementing the assertion part of your test. So usually that last few lines where you're making sure that the structure of the data or what happened actually did happen the way you think it does. So in terms of how that actually works in practice, the first time you run a test with snapshot testing, you pass some arbitrary structure of data. So, if you're creating a user, that the data might be a person object, and you pass that to your snapshot library. So the first time that executes, it goes through a flow where it will serialize that data, and then it'll write that data to disk. And it will also pop up an experience where it asks you to confirm that the data is correct. So what happens is you run your test and you have some kind of experience where the test will fail because it's the first time it's running. It will show you a comparison of the before and after, which will effectively be the before is an empty file and the after will be a serialized representation of that data. And you'll get a compare tool pop up. So, think your diff tool when you're doing, commits in GitHub or in Git. And then if that is correct, you confirm that it's correct through some mechanism, and it will copy that file from the one side to the other, and the resulting file is now your snapshot. So that file gets committed to source control. So that's the representation of the results of that test. So in the case of creating a user, it might be the serialized representation of first name, last name, age, for example, or date of birth. The serialization technology is kind of up to you in terms of snapshot testing. You could serialize it as XML, as JSON, or whatever. In the case of my tooling, Verify, it uses JSON to serialize that stuff. So that's the first time that happens, and now you have that representation of the result of that test in a file on disk. That gets committed to source control. So ever after, when you run that test, what happens is it goes through this similar process, but instead of creating a new file and asking you if it's correct, it will serialize the data coming through on the subsequent run. So now you've got the existing data that you've read from disk, you've got the new data that you've reserialized from running the test again, and you can compare those two things. If they're the same, the test passes. If they're different, you go through the same workflow of you get a pop-up that shows you the before and after. It will highlight the differences because that's what diff tools do. And then you have a mechanism where you can say, yes, that's correct, in which case it will copy the new file over the top of the old file, and you've got a new snapshot. If it's not correct, you decline it, and it will close the diff tool, and you have effectively a failing test that you need to now remedy, where you can go through and fix the code. Maybe it's a bug. Maybe there's something that you want to roll back, but you basically need to resolve that failing test. Does that all make sense?
Yeah, sure it does. So what I'm hearing is that the only difference with this approach that you are describing is that instead of doing assert on manually on specific properties or creating the expected object in the tests, I would just run some verify method on the actual object, and then it would be serialized and I would compare. Is it
That's
I'm
exactly right.
describing?
Yeah. So usually, for most people, snapshot testing will be a new technology. It's not widely used when compared to how many people are doing traditional assertion. So if you're converting from assertion-based code over to snapshot testing, usually you just delete all of your assertion code and replace it with a single call to a verify method. Or, execute snapshot method is effectively what it is. In my case, the tool's called verify, so the method is verify. You don't have to delete all your assertions. You can have assertions sitting side by side with snapshot testing. That's fine, but for the majority of assertions, they become redundant once you move to snapshot testing. So, for example, if in our case of create user, you assert the first name's correct, you assert the last name's correct, you assert the date of birth is correct. But once you move to a snapshot testing approach, all of that stuff is serialized into the snapshot, so those assertions now become redundant. There's a few cases where assertion still makes sense. For example, if you want to ensure something finished in under a given time span, so let's say, we want to make sure that this method finished in under 5 seconds. You can't snapshot test that because that's a range. You can't write to the snapshot how long it took because that's unstable. It'll be different every time. So often certain cases of assertions can sit side by side with snapshots. It's not a full replacement.
Yeah, I was thinking about something like, verifying that something only ran once. That was something that verify would not be able to do, because it's not an object you're trying to do. You're trying to verify against a count of executions, right?
So that actually is a scenario that can be supported, because how verify works is you can assert anything. So in the case of, let's say, our create person, and you are concerned, if you're doing message-based processing, you might be concerned about making sure things don't execute twice in some kind of arbitrary piece of code, like you said. So what you can do is you can have some kind of, if normally you'd be asserting on that data, so you have that count coming back somewhere in memory, right? You've got a execution times it ran in memory in the test. Normally you go assert equals 1. In snapshot testing, you've got a person and you've got the count, where you can actually just verify supports basically dynamic objects. So you can just go new count equals the count, person equals the person, and it will just serialize that for you. Right, so have syntax in .NET where you can just new brackets anything. It's basically a dynamic object in memory. It doesn't actually need a class or anything. That will serialize correctly. So you can arbitrarily pull in all these things in memory that you have. So you can have a count, you can have, the SQL statements that it executed as part of doing that method. You can have any web service calls that it did as part of that method, and you can pull all that together and stick it inside the snapshot.
Okay.
Right.
So what was the impetus of this? What you just sitting around one day and wanted to come up with something better than assertions, or?
Look, I didn't create this. I can't take credit for that. This predated my efforts with Verify. So I'm not sure which technology started it, but there's a guy called Llewellyn Falco who he runs a project called Approval Tests. And Approval Tests is more language agnostic in terms of there's similar implementations that he's implemented in 5 or 6 different technologies. So there's one in Java and there's one in .NET, et cetera, et cetera. So I got interested in that when I saw some videos of how much it could simplify testing. And I contributed a fair bit to approval tests. But I wanted something a bit more powerful. So the difference between verify and approval tests is approval test doesn't really have the concept of the serialization. So if you want to do serialization of things together, you need to handle that yourself. So it expects you to pass it a string effectively, where verify is very much on the, we'll take control of converting any arbitrary structure into a file on disk. So I created verify as kind of an evolution of previous work from other people.
Okay.
Does it work with the way you're describing it? Sounds like it should work with basically anything, right? I can pass like some objects, properties, anonymous objects, or whatever else. Is there any place where I cannot use verify?
So there's a couple of caveats there. So ideally, serializing an object, the result should be human readable and human comparable and machine comparable. Okay, so what I mean by that, so let's take the case of JSON. JSON's fantastic, or any text-based serialization is fantastic because you can write it to disk, you can read it using just any text editor, you can compare it to another arbitrary serialized text file and see the differences, and a machine can look at those two things and can compare them, right? So that's the ideal scenario. There's slightly, it doesn't have to necessarily be human readable in a text editor. Take the case of if you're snapshot testing a UI, how do you do that? Well, let's say if it's a web browser you're snapshot testing, you can take an image of that file, of that browser instance, and you can say, this is what it looks like. So you get a PNG. Now that's not really human readable per se because it's a binary format, but the tooling's good enough that it's a ubiquitous format and everyone has tooling that can actually read it. And it is machine readable, obviously, and it is machine comparable because all those diff tools that you have all know how to compare two images. So that's the thing where, it has to be serializable, yes. It has to be comparable by a machine and a user, ideally. Right. So if you take a format that wouldn't play well with that is, if you have an in-memory representation of a Word document, then the serialized representation of that is on disk a docx. A docx is, not really easy to read what the actual contents is because you can change settings in a document file, you can change styles, and those don't have a visual representation until you actually apply those styles in the document. So the doc can change and there's nothing visual that you can necessarily see. They're difficult to compare because if you have a snapshot of a Word doc before and after, there's very few compare tools that can actually take two Word documents and give you a representation of what's changed between them. So that's an example of a serialization format that is not ideal. So in terms of the serialization and verify, like out of a box, most people are used to, when they're playing with verify, they're used to the JSON representation, but verify actually supports any kind of serialization. So you can pass it in an instance to a browser tab if you're using Selenium or Playwright, and it will serialize that to two files, HTML and an image. So that means you have a text representation of what it looks like as well as an image representation of what it looks like, and it snapshots those to disk. If those ever change, then you can compare both those files. So if we go back to the previous example and apply that approach of what's a better way to represent a Word document, Verify has a way of basically looking at a Word document and going, well, that's not a great format to snapshot. So let's convert that Word document to multiple different images of one per page. So it will split the Word document over into one image per page and give you multiple files on disk representing that Word document.
Okay, and ultimately you need to push all those files to the repository. From the practical perspective, is this a problem? What if I have like thousands of tests? When does it become, troublesome to push all those files to repository?
So the majority of files are text. And again, the majority of files are relatively small. So, in projects I've worked with, most files will be, a dozen lines of text. Maybe some big ones will be a couple hundred. I haven't seen any hit the limits of that kind of stuff yet. There was a couple times when we were looking at snapshot testing large Word documents, which could result in multiple images. PNG is a very good format for representing, in that case, representing Word docs or even web pages because of the compression it has. As long as there's lots of colors that are all the same in groups, it compresses very well down to a relatively small file, which for most web pages and for most documents that makes sense. In our case, when we had a large Word document with lots and lots of pages, there's Verify has settings in it where it can say you can dial up and down the resolution of those images. So you can, effectively shrink them down so they don't take up so much storage on disk. Also, in a lot of those cases, you might not need all of the pages to be confident that the test has actually worked. So you might snapshot, the first subset of pages or maybe significant pages. So it's the same with assertions. If it is expensive to do assertions, you pick and choose what you do. Maybe you have different ones that run in different scenarios. But yeah, I haven't hit any practical limits in terms of committing this stuff to source control.
So does this just
Okay.
tell you that these two objects, the snapshot and the object you're testing it against, just don't match, or does it give you more details of that? Because like the reason you have multiple assertions is because you can have different, conditions, messages, whatever, to say what's not, expected result or expected value. So how does verify handle that?
So I am going to do a quick share. I'll just
This is geared towards podcasts, so you have to describe.
yeah, no,
So
I am going to
yeah,
explain. I
okay.
ran this past Adam earlier. So let me know when you can see my screen.
Yep.
Um, okay, so on the right we have our traditional assertion-based approach, where we're testing something that finds a person, and we're asserting all the results of that. So asserting first names, last names, addresses, quite complex assertion-based code. And you can see the signal to noise ratio of that is a bit skewed, because you effectively have 90% of any given test is assertion-based code. On the left, we have the same thing where we're just passing it to verify. So, and it's just reading the person from the method that's under test, and we're passing it to verify. We have a couple of extra settings there, but we can ignore those for now. So if I just come in here, and I'm just going to break the test by changing what's on disk in the snapshot and then running this. A couple seconds. Okay, so the experience I said, where you have a diff tool will show you what's changed. So what we're seeing now is I've broken the test by changing the file on disk, the snapshot on disk, effectively changing what we're expecting, and rerun the test. And of course, the test has gone, well, we still receive the same data, so it's now different between what we've received and what's on disk. And that's the experience you have, where you have a diff tool pop up. Now, if this was an image diff, you would have an image diff pop up. If it was multiple, if you were, say, splitting a Word document into multiple different files, you would have multiple images pop up. Sorry, multiple diffs pop up, each one showing a difference of the image. Does that, am I explaining that okay?
Yeah. So, but now I'm thinking, okay, this is fine if you're sitting there running the test yourself. But if this test was running in like a CI/CD pipeline or something like that, it's not going to, throw up a diff tool.
Yep,
And
exactly. Yep. So what happens in CI/CD? I'll just stop sharing so I don't explain what's on the screen again. It's a habit. What happened in CI/CD is Verify is aware of all the major CI servers. So it knows it's running in CI. I think it supports probably 6 or 7 of the major ones. And there's also a flag that you can say, oh, based on this environment variable, it's running in CI. And when it's running in CI, the behavior is slightly different. So it still does the compare in the two files, but obviously it doesn't pop up a diff tool. There's no interactivity there, so it doesn't do that part. So what happens is, by default, when the test fails, in the output of the test, it will actually dump you the before and after. So it will say, this test failed. We expected to receive this text. We actually received this text. And it'll just push from into the output of a test before and after. So you can see that you can eyeball. That's what I said about it's ideally you want the serialization format to be human comparable, right? And that's that scenario where, in the output text is great because you can just look at it and go, oh no, this has changed. What also happens in CI is that it will copy those things to the output of the CI. So when you do a build on a server, there's this concept of build artifacts. So verify when you run those things, if there's something wrong, it will pump the failed file to the build artifacts. So you can actually look at the failed build and actually go and have a look at the, in our case, it was a JSON file. You can look at that JSON file that's failed and have a look at the difference. Now, that's helpful because when we're dealing with a serialization format that is not as easily human readable, so for instance, an image, that any images that are different, it will copy those to the output as well, right? So that means you can actually have a look at those images. What you usually do is you download it and you overwrite the snapshot on disk of that image. So, let's say a Word document produced a single image. Oh, it didn't work in CI. You go and download the file the new file that was received in the build artifacts, and you overwrite on disk the existing snapshot file. Now, what you've achieved there is if you now go and look at your source control tooling, it'll say this file has changed, and because any of the good source control tooling recognizes what an image is, it will show you a before and after of those images. Right, so you can do an eyeball on those images and say what's different. So ideally, you want stuff snapshotted to text because that's one less step. You can have a look at the build output and understand what's wrong. You don't need to manually download things. But that is the scenario where your tests have already passed locally and you've pushed up to CI. So it's very rare that you have to do that kind of thing. Sometimes there's differences about, you're using environmental variables and snapshots and things don't behave quite right. But ideally, it should be a rare scenario that you have, snapshot tests fail in CI that don't fail locally.
And what about things that are somewhat random by their nature? For instance, I can imagine I have a class that has, I don't know, identifier that I'm not interested in when doing, object comparison. I can mark this identifier property as JSON ignore or whatever, and I could compare those things. Or I could even write my own quality method for doing that. How does verify deal with that?
Yeah, so out of the box, there's the concept of scrubbers. And a scrubber is, in the simplest terms, it's a way to plug in some arbitrary code into the snapshot testing pipeline to manipulate the data before it goes to disk. In more practical terms, out of the box, there's several approaches to scrubbing that Verify has. Two of the most common ones are date times and GUIDs. So when Verify is serializing an object, in our case, previous case, that person, they might be there might be an ID there, the user ID, and that's going to, every time you run that test, that ID is going to be a different GUID. So you can't snapshot test that GUID because every time it'll fail. It's like, oh, the GUID's different every time. So what Verify does is, as part of a serialization, it goes through and it goes, I know that type is a GUID. So it takes that GUID and shoves it in an in-memory dictionary, and it replaces it in serialization with GUID _1. So when you actually look at that snapshot file on disk, it'll be GUID _1. Ever after in that structure, if it finds the same GUID again, it'll replace it with GUID 1 as well. So if you're doing more complex scenarios where, you're you're creating multiple objects at the same time. You're doing, companies and employees, and you pass all of that big structure to a snapshot test. It will go through and you'll have, all the good ones will be correctly correlated. So you can look at that and on disk, and you can see that the employee ID is good one, but it's also down here referenced in the list of employees for the company. So you can effectively tokenize it in a way that you can understand. Right. So it replace all the same goods with the same token. And then on disk, it's consistent. So, and there's a slightly more advanced concept in Verify where you can actually name certain goods. So when you do the call to create your arbitrary data structure, you get back your instance, and then you can say, look, for the person.id, I want you to call that person ID, a string called person ID. Now, when it serializes that, anytime it finds that ID, it will replace that GUID with person ID. So it will give a name tokenization to that, so it's a bit more readable. But out of the box, it's just GUID 1, GUID 2, et cetera, et cetera. So the same applies with date times, right? If there's, let's say, you have a modified date on the person when you created it, or a created date, it'll go through every time it hits a date. It shoves that into an in-memory dictionary. It'll replace that on disk with, date time _1. And if it finds that date in any other property, it'll use the same value on disk when it serializes. And again, you can have named date times as well.
Okay.
So
that sounds good.
Yeah. Go ahead.
So the named GUIDs and date time approach is also helpful for, in our case, we have a lot of, lookup data where I work. So we have, when you're testing, you use a common, a common user for testing against. You have a common, address that we look up. So basically all those things are in memory that we just use when we're doing testing. And in a static context, for all the IDs of all those things, we build up common consistent names for all the IDs of those things. So that any time in any test where it finds, we have an admin user, we have an acting user, and we have a receiving user, we have named IDs for each of those things. So anytime it finds any ID in those structures, it will properly replace those IDs with the lookup value. So you can have this kind of, common known GUIDs and date times that are replaced statically for all your tests to get them more readable. So that's the kind of that's two of the built-in scrubbers. There's other use cases for scrubbers where, in one of the cases where we commonly do is converting PDFs and documents to HTML. So in the resulting HTML that we get, the tooling that we use puts some metadata at the top. So it's third-party software of the version number that generated those documents. So it means anytime you do an update of that tooling, suddenly your snapshot test breaks. So you can have a scrubber that goes, oh, just remove all lines that have the text, version. And it will, as it serializes those, it'll just, scrub those out so they don't appear in a resulting snapshot.
Okay. I have two questions to that. This idea of scrubbers sounds interesting. One thing that often kicks me when doing unit testing is like asserting on collections and verifying whether the order matches or whether the order is not important. How does Verify deal with that?
So there's a bunch of settings around order. So things that are out of the box ordered. So think your list structures. It will serialize those in the order that they appear in memory. So things that are by their nature unordered. So if you think a dictionary in .NET, while the order might seem consistent if you iterate over all those items, it's actually considered non-deterministic. There's no guarantee that in the next version of .NET, that order will be the same. So Verify has opinions for those kinds of structures where it can order based on the key, for example. Right. So there's a bunch of different settings in the serialization in Verify where you can either respect and treat the order as it is, or you can apply an order to various structures so that effectively we don't care what order we got them in, we're going to order them as we write them to disk by some key or some value. Right, so it depends very much on whether you consider order to be important. So you can plaster over that and say we don't care, or you could say we do care, in which case it's just writing what's in memory to disk in the order that you have, and it will blow up if it's out of order.
Okay, that sounds good. And the second question I have, quite often I'm seeing tests that, for instance, when we are dealing with serializers or ORMs or whatever, the logic of the test is basically I create an object, I give it to, let's take serialization library, serialize, deserialize, and then I verify whether the object I got matches the initial object. And for doing that, people often use things like Faker or AutoFixture or whatever libraries that basically create an object filled with random data that differs between every test execution. Can Verify be used in these tests? Or because when I'm hearing it sounds like it can't because it would snapshot the randomized content, but maybe I'm missing something.
No, so yeah, in that scenario where you've got truly randomized content, no, that's not a good scenario for snapshot testing. But having said that, all those, you're talking about Faker, there's also a .NET one, which is bogus. All of those tools have the concept of an input random key. So that's something that you pass in where, you could use the name of a test method as the key. You could use, whatever you want, but as long as it's consistent, like it could just be a number that's passed in as the random key. It will give you when it runs that, it will give you random data. But first time you run it, it looks random, but because you're using the same key, the next time you run it, you will get the same data set. Right? So it means that yes, you get the value of, I don't want to manually construct these objects because that's what you're trying to avoid, but you still have a reproducible, consistent data structure to actually do a snapshot test. Now, having said that, for most tests that makes sense, but sometimes you are testing a method and you do want the randomness, right? You do want to, every time you run it, I want to throw random data at this just to kind of catch edge cases and try and break it and, nullability issues. That's not a good case for snapshot testing, but so you would still use your old approach for that. But each time you find one of those cases that it does break, so let's say your random generated data created, an empty list for phone numbers, right? And that blew something up, right? Well, in that case, you would take that scenario and you would write a proper test for it, so that you have a test that says, oh, look, we wanted to test and make sure that empty list of phone numbers doesn't blow up. And then because that's now a consistent test that you've kind of harvested from that randomized data, you can now run a snapshot test against that. Right, so they can work together, but truly randomized data is not a good scenario for snapshot testing.
Gotcha. One
How
thing
about if you have a test? Yeah. How about if you have a test that you're using against multiple parameters to pass in? Does Verify know? Does it detect which parameter set it's running off in this execution and based a snapshot on that?
Yeah, so Verify has out-of-the-box support for parameterized testing. So what happens is it plugs into, it's got extensions for all the main testing framework. So it's got an extension for XUnit and NUnit and MS Test and Expecto and all that stuff. So most of those libraries in the test execution context, you can ask for library and say, give me the parameters that are currently being used for this test. So Verify then takes those and it will convention-based plug those into the name of a snapshot file. So if if you've got a first name and last name parameters that you're passing in and you've got 10 scenarios with different combinations, the resulting snapshot files on disk will have those values actually in the file name. So it means each scenario actually gets its own file on disk with those key value pairs in the file name.
Okay, nice.
Yeah. So that's, for the majority of stuff, that's seamless. There is a few edge cases where Verify can't detect the parameters because some of those APIs are purely dynamic and you just can't get the current parameters out of the test context. So in those cases, there's an override where you can take control of the snapshot test file name and say, oh, use this parameter with this key and value, right? And it will respect those over the top. So you can take full control over the file name.
Cool. One thing that came to my mind, and it may sound crazy, but still I will ask it. Like, it sounds like this library has tons of useful logic. For instance, taking those pictures of docx documents or whatever. Could I use it like outside of the tests? I mean, in my production code to, for instance, provide like diffing logic for inside my product. Would it be possible to use Verify for that, or is it super like customized for CI/CD and test?
So there's a couple of scenarios there. So under the covers, the diff launching logic where you saw a diff tool pop up with a before and after, that I've split that out into a different library. So if you want to provide an experience where you can launch diff tools, there is a facility to do that in its own little standalone library. It's not even about snapshot testing. It's just launching diff tools. If you want the experience of doing the serialization and comparing objects and all that kind of stuff, there is a low-level API in Verify where you can actually use that stuff. It's not as well documented and it's not as as polished as the top-level one because it's not a common scenario, but there are a few people who are actually using it. So yes, that is possible.
Okay, sounds good.
In terms of, I should touch on the snapshot management stuff as well. So when you saw that that diff tool pop up earlier, where you have the before and after, so the flow of how that works is fairly configurable in terms of how you whatever your preferences are. So for me on Windows, I run Rider. So when I run the tests, I get that diff tool pop up. And you want an easy way of accepting or declining that change. So if you think of that one diff tool that popped up, that's great. I can manage that. If I want to accept the change, I could use the button in the diff tool to say, copy from left to right or right to left, depending on what your preferences are, where you're basically saying, look, accept this change. If I want to decline that change, I could just close the window. Right? So that's an accept and decline scenario for one file. That works well. But let's say you have 1,000 tests and you change that a snapshot testing, the HTML produced for different pages in your website, and you change the header. Now, every test is going to break, but you can't physically launch 1,000 instances of a diff tool on your box. I mean, unless you have a lot of RAM. So you need a better way of managing that. So when Verify runs, it has a concept of maximum diff tools to launch, and that's configurable out of a box. I think it's about 8. So if you have 1,000 tests fail, what happens is you'll get 8 instances of different diff tools, different instances of a diff tool showing you effectively the same thing. And even 8 instances is a bit of a pain, because if you wanted to manually approve all of those, you'd have to go, click the same button in all eight instances, close all of those instances, and then, well, you've done 8 of 1,000. Well, to launch more diff tools, I'd have to run it again. So you can see where that's kind of very quickly became unmanageable in terms of the user process, which would be enough to say, well, snapshot testing's not worth it for those scenarios. So Verify has this concept of, kind of advanced snapshot management. So when you actually run all those tests, they all fail inside your IDE. You get your subset of diff tools pop up. So if you want to bulk approve those, in the scenario where, look, I know I've done one change that's going to break all the tests, I want to accept all of those. So if you're in Rider or ReSharper, there's an extension for both Rider and ReSharper where you can right-click on all your right-click at the root of the tests and say accept all changes to verify, and it will automatically accept all those things. There's also a Windows tray equivalent to that, where there's a tray tool that sits in the bottom right of your Windows box, and you can bulk approve or decline any number of failed snapshot tests down there. So if you have 1,000 tests that have failed, you can just right-click on that thing and say accept all of those changes. You can also accept based on various groupings. So accept all the failing tests for this test or that test. And also that snapshot tool also monitors multiple instances of your IDE. So if you have multiple IDEs open, all using different snapshots at the same time, it will group those things for you, and you can manage different snapshots for different IDE instances in your tray tool. There's another scenario you can actually use, which is a console tool. So you can bulk accept or decline snapshots from the console as well. So there's always kind of, extra tooling around that to make that a more pleasant experience for you. Does that make sense?
Can you tell Verify to ignore a certain property? So maybe you want to use the snapshot testing against the most of an object, but maybe one property you actually need to write a real assertion against it. Can you do something like that?
Yeah. So there's Fluent APIs for that falls under the scrubbing scenario as well. So you can effectively scrub a property, or you can ignore a property. So by scrubbing, I mean it will replace that property with it's the syntax is bracket scrubbed, right? So it means that the property did exist, but we don't care what the value is, and here's a string representation of that. So you want to use that when you care that it has a valid value, but you don't care what the value is. And then there's a concept of ignoring a property, and that's where you can just say, look, ignore that completely, and it just won't show up in the serialization at all. Right? So they're two distinct. I mean, there's a difference between those things, because sometimes you care that something has a value, and sometimes you don't. So there's different APIs for that, and that's a Fluent API where you can, it's the Lambda expression approach to, for this type, ignore this property. And I should say now that stuff, that API has both a static global configuration and also a per test configuration, and that's the same for almost all the settings in Verify. There's a static global configuration, there's a per test configuration, and there's also a scenario where you can have a settings instance that you can reuse for multiple tests, where you have a subset of settings for how you want Verify to work, and you can pass that settings instance to different tests and reuse those settings.
This almost seems too good to be true. You're telling me that I can replace 90+% of my assertions with just one line saying verify and go from there. It seems it's like, yeah, this is awesome. I think all the test tooling providers should be including verify in the box.
It's not, I mean, I'll go through some of the drawbacks. I mean, I've already touched on, some things don't map well to snapshot testing. You talked about, truly random data. We also talked about, finished in certain time. So you still need assertion-based code in your code. The other drawback is you have now moved, you've now this split brain scenario where a given test now has the snapshot for that test and the assertion is in a different file, right? So that's not great because now previously you could look at some assertion-based code, and yes, it might have been verbose and it might have been a bit more difficult to understand than a serialized snapshot, but it was in line with the test, right? Now, in line with having what the data should look like in line with the test is clearly better than having it split out into a different file. Right. So that's one of the drawbacks. I mean, for me, I'm used to the flow and it doesn't affect me as much. So if I'm iterating a lot on a given snapshot, I'll open up that snapshot in the IDE and do the split tab thing where I have the snapshot over here of what it should look like and the code that I'm testing over here. So you can actually have a look at them side by side. There's also a thing in Verify where it will, in your IDE, there's a feature in .NET where you can nest files under other files. So you'll often see it in terms of, often if there's some kind of code generated file, there's some features in .NET where you can nest that code generated file under the parent file that it's associated with. So it means it's expanded out in the Solution Explorer. You've got a little thing. If you expand out the file, you can see child files under it. So Verify plugs into those features of MS Build so that any snapshots you have, it knows what snapshots files should be nested under a given test file. So if you are looking at a given test and you expand that test in the Solution Explorer, you'll see the snapshots for that test directly underneath that file. But that is kind of plastering over the fact that ideally it would be good to have what it looks like co-located in the same test. So it's not ideal. Some people, the first time you start to try this, people kind of push back against that, splitting that out. But for me, and I think most people who played with it, very quickly the benefits outweigh the disadvantages. And I should say as well, in terms of, you were talking about earlier about the limits of committing these files to source control. While I haven't hit that limit, it is clear that if you're serializing and doing memory replacements of scrubbers and all that kind of stuff, that does take time. We're talking milliseconds to serialize something to disk, but still it does take time. So traditional assertion-based code, asserting some things in memory, you're talking in the nanosecond time frame to do some assertion. In snapshot testing, you're talking in the millisecond time frame. So if you do have a lot of tests, we're talking tens of thousands, hundreds of thousands of tests. And that might seem like a lot, but if you're doing, parameterized scenario testing where you have vectors that multiply, right? You've got, 10 parameters, and then you're doing all the combinations of those parameters, and you're doing it at multiple tests. You can get into the scenario where you have, the kind of the hundreds of thousands of tests scenario. Now, in those cases, snapshot testing might not be good just because it takes too long. I haven't hit that yet for any of my scenarios, but I'm sure some people would. If you're doing, low-level mathematical matrix computational stuff, and there is a lot of scenarios and you want them to run really fast, snapshot testing is not for that. You want your test to run so fast that you want to do in-memory assertion in the test. But in those cases, it's a combination. Like, as I said before, snapshot testing is not a pure replacement for assertion-based testing. It's a complement to it. Yeah.
So are there new features coming to Verify, or is it pretty much feature complete?
I generally, in terms of new features, there's often scenarios where people, come and look at it and play with it in different ways that haven't thought of. So there's often kind of this, a new feature because someone found a scenario that I hadn't considered. So, it probably gets a release every couple of weeks of things like that. There's also a bit of, playing catch up with various tools. So I currently have it supporting .NET 9 because I want to, ensure that when .NET 9 drops, it works and supports it. But there's also, there was recently a new version of NUnit, so I had to make some changes around that. Sometimes the features that I want to do in Verify haven't been exposed in easy ways in the test framework tooling. So there's some long running, like I've got some features that I want in XUnit that I expect to be added in XUnit 3, which might drop might drop this year, might drop next year. And I'll release a new version of Verify when those features come out. So there's always kind of stuff going on there. Yeah, so it's fairly active.
Okay, that sounds good then. And it was pretty lengthy discussion, so thanks for walking us through this great library. We encourage all our listeners to try it out because it seems like you could cut down your test code by 90%. And I know what Shawn is going to do next week. So hopefully it works for you folks. And that being said, I think it's a great time to move on to picks. So I can begin with the picks for this week. And my pick is actually, this time, it's a little bit of a self-promotion. So let me just share a link to my blog. But the whole point is, whenever I use RDP, remote desktop connection, I always find it irritating that the incoming audio is often delayed. And I was kind of doing my PhD recently of why it's the case and how to fix it. And I basically hacked the MSTSC to get the audio, like fixing the audio delay. So just sharing this link, if you ever experience that MSTSC and the audio, they are like irritating, there is a way to hack all of that. So take a look at those. And yeah, it works for me. Hopefully it works for you. And over to you, Shawn.
Yeah, so my pick this week is the new Star Wars series, The Acolyte. So I've been enjoying watching that, because I've always liked Star Wars and remember when it first came out in the theaters. So one interesting thing about The Acolyte is it actually messes with the Star Wars timeline if you were trying to watch all of the movies from beginning to end, because this series is actually prior to Episode 1, The Phantom Menace. So now if somebody wants to watch everything from beginning to end, they have to start with The Acolyte and go through 1, 2, 3, 4, 5, 6, and so on and so forth. So that's interesting. So if you're like Star Wars, check out The Acolyte.
Cool. I back that. The Acolyte's awesome. I've got a couple of picks. So one, I'll include a link to this. I've got a little library called Polyfill, which backfills around 200 APIs and .NET features back to your early .NET Core and also early versions of .NET 4. So it targets net standard, and it allows you to basically use features and APIs and code like you're in .NET 8, even when you're targeting older versions. So I'll give you a link to that. The second one is there's a mostly unknown feature of NuGet where you can set a few settings in your directory props, and it will notify you whenever there's any NuGet package that has a CVE in it. So it means in your CI, if say there's a CVE in the SQL client, which has been several in the past few months, it will break your build with a nice little error saying this package has a CVE, and here's the URL of how to go and fix that. So I'll give you the settings to go and put that in your project. Highly recommend it because it's security checking for free. I don't know why it's not on by default. Cool.
Yeah, life happens. Okay, Shawn, I will let you land the episode as I started it. So over to you.
So yeah, I last thing before we close out is just if our listeners want to get in touch with us, they can reach out to me. I am on X/Twitter. I am at .NET Superhero. We'd love to hear your feedback or ideas of future topics we should cover. So let us know. Thanks, Simon. Thanks, Adam.
Thanks
And
so
we'll
much,
catch
guys.
everybody else on the next episode of Adventures in .NET.